According to U.S. Energy Information Agency, 83.1% of America's energy in 2016 came from non-renewable resources. However, as environmental problems like climate change become more prevalent, it's crucial to find alternative sources of energy. Our project is modeling tall wind towers, and our objective is to mathematically and visually model wind towers of different heights using the softwares Octave and Abacus. We also want to optimize tower models for material efficiency and durability.
During the first week, we read papers on the background of wind towers, the reasoning behind taller wind towers, the basics of mechanical behavior, and materials for wind towers. We also learned the basics of Octave. We use this programming language in our project later on. To practice modeling objects in Octave, we modeled basic physics problems, like applying force to the end of a fixed steel bar.
Week 2, we had our first weekly meeting with our professor and other graduate students. For the rest of the week, we did more complex Octave modeling. We first modeled a steel tube and then advanced to modeling concrete towers. We added more forces like shear forces and wind forces. Since the second part of our project was to model these same objects in Abacus, we also learned the basics of Abacus during this week. We practiced creating parts, assigning materials, adding loads, meshing, and running simulations to test our designs.
In the third and fourth weeks, we continued to model wind towers in both Abacus and Octave to calculate the stress on the tower. In addition to just the tower, we added other parts like the blades and nacelle. Now that we learned both Abacus and Octave, we used both to model simulations to see if the results matched. While we used MATLAB to find the results analytically, we used Abacus to find the results through FEM software.
In the fifth and sixth week, we finished modeling the wind towers. We ran into some problems getting the results from Octave and Abacus to match, so we spent most of the week troubleshooting these problems. In the end, we were able to get matching results when modeling a 100-meter tower with gravity and wind force loads applied to it. We then put our poster together with all of the models and graphs that we generated. In the sixth week, we mostly prepared for the final presentation. We put together our slideshow and started editing the clips that we had filmed throughout the camp.
In conclusion, we learned how to model objects in both Octave and Abacus and gained valuable insight about the research process. Through reading papers and doing hands-on simulations, we deepened our understanding about wind towers and the field of mechanical engineering.